Okay, so today we'll be talking about oscillatory motion. The first topic of oscillatory motion is motion of an object attached to a spring, because that's the best way to kind of describe oscillatory motion. So first, picture's image. So there's a spring here, and there's a mass attached to it. And so right now it's stationary, nothing's happening, no one moved the spring, nothing happened, right? So, but let's assume that you take this little spring with your hands and you move it to the right. I mean, not spring, the mass. Now, what happens is, when you move it to the right, you're putting it in this stretched position. And there's tension now with the spring. And you displaced it with a delta D. So what will the spring do? It'll naturally go back to its original position, which is x equal to 0 right here. It'll try to go back to its original position. Now let's assume that you compress it. Let's assume that instead of stretching it, you compress the spring. So what will the spring do? It'll go back to its position in the middle, where it was at before. And so that's how springs work, right? When you compress or stretch it, it'll want to go back to where it was before. And what happens here is, when you compress it, yes, it'll go back to its position before, but it'll actually go beyond it as well. It'll go beyond. It'll reach this equilibrium here at the final point, and then it'll go back. And it'll continue doing this, back and forth, until it loses all its energy. So what we call this force is called the force of a spring. People call it the Hooke's law. It's also pretty valid. So this consists of the spring constant K and X, how much you displaced it from its equilibrium. If you displaced it to the left, this X will be negative. If you displaced it to the right, this X will be positive, depending on which left and right you make positive and negative. And this K, what this K represents is how stiff the spring is. It's how, that's a way to describe it. So how stiff the spring is, how much tension the spring has. So that's what this K represents. It's a constant. It'll be mostly given to you. You can somehow solve for it as well, sometimes. So now we can consider this to be a particle under net force, because there's this spring force that's acting on this particle.